Hello, my name is Kayla Boza, and I did a research paper on advances in earthquake design. Um, Earthquakes, have a huge impact on our lives and on our infrastructure and our economy. We face a lot of challenges in the preparation for earthquakes and the mitigation of the earthquakes. In the geotechnical engineering role that this has, is it focuses on designing structures that can withstand seismic forces, including site assessments, advanced modeling, and innovative technologies. Well, what does that mean, right? Well, systematic isolation techniques would be examples as base isolators, which are devices between foundation and superstructure. They reduce systematic forces, protect crucial infrastructure like hospitals. Another way would be damping systems, which means that it would absorb and dissipate systematic energy. Examples would be like fluid viscosity, tuned mass, friction, dampers, stuff like that. Economic and safety benefits that this would have is it would minimize structural damage, enhance occupant safety, and reduce post earthquake repair costs, which all sound pretty good. And then performance based systematic design, also known as PBSD. Its main objective is design structures to meet specific performance goals such as immediate occupancy, operational functionality, all of that. A detailed analysis would be simulated building responses under different systematic scenarios to optimize design. And the importance for this crucial infrastructure is it ensures essential services remain operational after an earthquake. So, they have to build buildings and they have to make these things strong enough to withstand those type of, shakes and stuff like that. Liquidation, migration. Liquidation is the saturated soils lose strength during earthquakes, leading to instability. So, if the soil of the building isn't well constructed, or there's not it's not saturated enough, then it weakens and it can make the foundation of the building actually collapse. Even if the building itself is made for earthquakes, that doesn't necessarily mean that the foundation and the soil is also. So how can we improve that? There's something called vibrocompaction, which is kind of like when you think of shakers and you think of when you have to seize the soil, you compact it into smaller so it becomes harder. So people do that, when you're compacting even sand, for example, or if you wet it, then it makes it tougher and it makes it withstand better, things like that. How are you going to be able to keep up with that? Another thing would be grouting, deep soil mixing. Enhanced soils would enhance the soil stability, which is ultimately a way that we can ensure that those things won't happen. Another one would be advanced numerical modeling, which is simulation tools which account for non-linear soil structure interactions, improve accuracy in systematic analysis. Applications would be optimize structural design, select materials, and develop retrofitting strategies. Soil structure interaction, also known as SSI. What is the importance of SSI? Well, it's understanding dynamic interactions between soil and structures for better design. Foundation types would be shallow versus deep foundations, or selection based on site specific conditions and the seismic risk. So, obviously, depending where they're located, not every place is going to have earthquakes, and not all of them have earthquakes, which is fine. So, it's not going to be needed in areas as much in those areas. Retrofitting techniques is fiber reinforced polymers. These are innovative methods, and it would be fiber reinforced polymers, extremely bonded reinforcement for enhancing systematic resilience. Applications would be cost-effective upgrades for aging infrastructure, preservation of historical buildings. Another topic is systematic microionization, which I talked about in the beginning. And the purpose of that is it's detailed maps to assess regional systematic hazards, guide urban planning and development. This will just help so they can try to catch earthquakes quicker, so they can have an understanding of how people can prepare for those when the time does come. The benefits is, it can target earthquake design strategies, improve land use decisions, and disaster preparation, so people can prepare better. Um, so some of the most interesting facts that I learned from diving into this topic was there was a ton of new technologies that were being developed. I could go on and on about all of the different ones, but it would just be a waste. It would be a waste of knowledge for everyone to hear that over and over again. But it's also being developed so we can help predict and plan for for natural disasters like an earthquake. Um, and it's kind of good knowing that people are out there trying to find alternative ways to fix it, trying to find ways to plan for it, because before there wasn't really any planning besides just hoarding and stocking up. But now, if there's technologies that can be put out there that can help us see those things, then more people will feel at ease and less stress will happen. So, in conclusion, that advancements in earthquake design are pivotal for mitigating systematic impacts, ensuring safety, and enhancing resilience. Ongoing research, continued innovation in geotechnical engineering to protect communities from future systematic events. Obviously, we can't control them from not happening, but we can be more prepared for them so that when they do happen, it's not as disastrous as it's been in the past. This class has allowed me to look beyond what the book has taught, but to expand and look into other possible problems that, people out there that are trying to solve, whether it's in geotechnical engineering, environmental engineering, any of the engineerings. It's always about finding a problem and figuring out a solution. And things that I would recommend for future work on this topic is finding out a way to make it accessible to the everyday people and see how the expansion of the technologies expand out and make it more common for the everyday household, so we can all be a part of knowing and being prepared. Lastly, I would like to think that the research that I found in this was a lot of journals and a lot of other engineers talking about their discoveries and what they did to change it and how they could improve it on it. And all of those journals and all of those books and articles were all extremely helpful in conducting all of the research that I found. Thank you.